Hello all. Let's begin our class. Uh, I updated the quiz results, and you can check whether your score is correct. And yesterday, I also updated the results of assignment 4. The submission deadline of assignment 4 is today at midnight. And some students get accuracy of -2, and this means you do not follow the instruction of assignment 4. You cannot modify re-student grades, and display semester grades. Especially, you cannot output additional new line after this message. You should only use this function, but not modify any cout statement. If your accuracy is not 100, and you should test all the input-output samples. And if you find your program output your program output are the same as input-output samples, then you need to pay attention to whether the variables are initialized. Because if you do not initialize your variable, this will cause undefined behavior, because the value of an uninitialized variable is unknown. And another issue is index out of range. This typically arises when you declare an array and its size is too small. And I also noticed suspected plagiarism. I saw some students seem to constitute plagiarism. And when you do your assignment, you cannot view or modify other students' program codes. And if you do this, you will get a 0 for the assignment. And the student who provide you the assignment will also get a 0. So you need to pay attention to this one. And I also updated the accuracy results of assignment 5. And I also provide more samples, more add samples and delete samples, and you can use these samples to test your program. You should pay attention to the scenario that you should pay attention to the you should pay attention to the scenario that if the input score is the same as some score in the leaderboard, then you should follow the instructions of assignment 4. So for example, we have 262, and you need to determine which item should be appear first. So And today we also will have the teaching evaluation survey. This survey will be conducted around 10:30, and after that we will have a roll call for the class. And we have finished strings and sorting, and this week we will learn structures and classes. For this chapter, we have 3 topics. The first topic is structures. This allows us to define our own data type, and classes are similar to structures. We can also use classes to define our own data type, and classes provide more features such as public and private attributes. And the third topic is object-oriented programming. And this is a programming paradigm. I will introduce some principles about OOP. So how to define our own data type? We can use structure. Here, struct is a keyword in C++, and followed by struct is the name of the data type. You can use the naming convention is the same as the one we define. We declare variables, and one convention is that the first character is usually in uppercase, and then we have a pair of braces, and inside the braces are member data of this data type, and you can use any built-in data types or other data types defined in the library. We already seen one example in previous chapter. For example, we have an example. We define a new data type student, and for this data type, we have 2 members. One member is student's name, and the other member is student's score. And the data type, so we have 2 member data, and we can we use this structure to pack the 2 member data as one object. And when we perform sorting, you can use this data type to declare an array. And when you perform sorting to this array, you can simultaneously move both name and score. If you don't use structure, you need to declare 2 arrays. For example, one array for student's name and the other array for student's score. And you need to deal with each array separately. After we define this structure, then we can start to use this data type to declare variables. And this is just like we use built-in data types to declare variables. For example, we declare car one is of the new data type automobile, and when we want to access its member, we can use the dot operator. And we can also simultaneously define a structure and also declare a variable. For example, after we define this structure, then we can before the semicolon you can add some variable name. So before the semicolon, I add car one, and this is the same as this page. After we declare this structure, and we use this structure to declare car one, and you can combine both. You can combine both operations in a single statement, like this. But I usually perform the first way, because the first one is more clear. If you combine two operations in single line, and this will lower the readability of your program. So I usually prefer the first. I usually prefer to separate structure definition and the declaration. And after we declare two variables, for example, car one and car two, and after you set in some values to the members of car one, then you can perform assignment. You can assign car one to car two, and this is equivalent to you separately assign each member in car one to the member in car two. So using structure is convenient. You can use a single assignment to replace 3 assignments. This page is about how to send a structure as function arguments, and we already learned how to send variables to a function. We can use call by value. The method 2 is call by value. We send car as the first parameter, and we can also use call by reference, which is method 1. If we want to use call by reference, then we need to add the ampersand operator. And if you do not modify car inside this function definition, then you can add the const modifier. So const means we do not modify car inside this function definition. And method 1 we usually prefer method 1 because method 1 is more efficient. If you use method 2, method 2 is call by value. Then when you make a function call, all elements, all member data of this car will be copied to this local variable. So when you make a function call to get car price, then the input parameter will be copied to this local variable. So car is a local variable for this function, and you need to copy each member of your coder to the local variable car. So this is less memory efficient. For method 1, we use call by reference, and when we make function call, we just send the memory address of this variable, and this is typically more memory efficient. So we prefer to use the method 1 to send structure as function arguments. The next slide is about hierarchical structures. This means when we define a data type, we can also use another data type as its member. For example, suppose we want to define a data type, personal info, and this data type contains height, width, and the birthday. And height and width are built-in data types. For birthday, we need to use some data. We need to use a data type date, and the date is defined by our own. So this is called a hierarchical structure. This means structures inside structure. And when we want to access its member, similarly, we use the dot operator. So you can set the value of height using the dot operator. And when we want to access birthday, then we also use the dot operator. And because birthday is of data type date, and date also has its own member, so we can also use another dot operator to access the members of the date structure. The next page is about structure initialization. For this data type date, we have 3 members, and we can use a pair of braces to initialize this structure. And this is similar to the initialization for arrays. When we want to initialize arrays, we also use a pair of braces. And if we omit some member, for example, we only specify the first 2 members, then the remaining member will be set to 0. And this rule is the same as the rule for array initialization. And if we only specify the first member, the remaining 2 members will be set to 0. But if you do not perform initialization, you only declare this variable. And in this situation, the 3 members will be unknown. So only when you use the assignment operator to perform initialization, the values of this structure will be set. if you do not initialize variable, then the values of this variable is unknown. And we have finished this the first topic. We have finished the first topic. So then we will go to the second topic. I will introduce classes. Classes are similar to structures, but classes provide more features. So structures only have member data, but for classes have member functions. And classes are important components of object-oriented programming. And we usually, when you use class to declare variables, and such variables are usually called objects. And the objects contains both member data and member function. Member function also called operations. Here is one example. We use the keyword class to define a data type. And inside the braces are member function and member data. So in this example, we have two member data, two member variables, month and day. And the output is a member function. We also have one additional this tag. We also have the public keyword. So here public is a keyword in C++. Public means anyone can access the members of this data type. In the following, I will introduce another attribute, private. Private is in contrast to public. If you change this attribute to private, then only the member of this data type can access private data or private member function. So we can do some practice now. We can use this class definition. in this example, I use this data type, day of year, to declare object date one. Then you can print its members, the value of its members, and currently the values are unknown. So you see some random number because we haven't initialized member data. Later, I will introduce how we can perform initialization to member data, and we will use constructors. I will show how to define constructors to initialize member data. I think next we will have a quiz, and please raise your hand if you need answer sheets. Anyone need answer sheets? You need to close your laptop and tablet until the quiz is finished. Oh, sorry, internet. The internet has some problems, so I will change the internet connection. So this is the first question. You need to determine the array size and string length for this character array. 30 seconds left. Then I will turn on the second question. Uh, 30 seconds left. Then I will turn on the last question. 30 seconds left. And I will turn off all the questions. If you use answer sheets, remember to write down your student ID and your name, and submit the answer sheets to me. Let's see the answers to the questions. Uh, let's see. Sorry. The teaching evaluation survey will be conducted at 10:30, and after that we will have a roll call. Let's see the answers. The answer is option 3. So for this character array, the array size is 10, and the string length is 9. So for this character array, new year, so new year, new space year. So here are eight characters, and \n is an escape sequence. So \n is one character. So here inside the double quotes are 9 characters, and we need to for the array size we need to include the null character, because this is a C string. So the last character of a C string is the null character. So 9 plus 1 is 10. So the array size is 10. You can use size of to obtain the array size of this character array. And the string length does not include the null character. So the string length is 9. So for this problem, the second question is syntax error. Okay. So let's see. Okay. Syntax error. Sorry. A for this. Oh, no, for this question is this is syntax error because for the first plus plus for string means string concatenation, and for the first plus we know that name one is a C string, it's a character array, and the double quotes is also another C string, and we cannot use plus to concatenate two C strings. So the first plus is illegal in C++. So the first plus will cause syntax error. However, if you change the data type from character array to C++ string, then the first plus will become legal. For the third question, the answer is option 3. We need to determine the elements inside this password integer array, and each element is determined by dictionary at index I minus character A plus 1, and each element in this dictionary is a character. So at index 0 is character D, and we know we can perform character D minus character A. So character D minus character A is 3, because the distance between the two characters is 3, and the 3 plus 1 is 4. So you can compute the remaining elements. So the answer of this question is 3. I think the time is up, so we can take a break for 10 minutes. Hello. I think time is for our class to continue. Uh, I will. I have one additional remark for the structure definition. Uh, when we define this structure, we actually no memory is allocated when you define a structure. Memory is allocated only when you use this structure to declare variables. So when you perform this statement, this statement does not allocate memory, and only when you use this data type to declare variables. So this statement, this variable declaration will allocate memory. And let's return to our example. Let's see the class example. And in this example, so we have the member data. We have two member variable, and we also have a member function. And the member function is like the ordinary function. So you can define any, you can put any function declaration here. So you can declare any function here. And then we need to define this member function. So the definition is outside this class. So I put the function definition after this class. Then we need to add a scope resolution operator, which is a double column. This means scope resolution operator. And this operator is to tell the compiler this function belongs to which class. So so I use this scope resolution operator to tell the compiler the output function belongs to day of year class. And then we can make a function call to this member function. So here I set the values I set values to member data. Then I make a function call to output member function. This member function will print the values of member data. And we know that if you omit this scope resolution operator, now suppose we omit. If you try to omit this scope resolution operator, then we cannot make this function call. Actually, we have a syntax error. This line will cause syntax error because months and day. We because if this function does not belong to this data type, then we cannot access its member. So if this function is not a member of day of year, then we cannot directly access months and day. So this line will cause syntax error. So you see that the error message is months was not declared in this scope because we cannot access months and day inside this function because this function is not a member of this day of year. So member function has member function can access member data, but outside so from this example, we see that we use dot operator to access member function or member data. And when we need to define this function, we need to use the scope resolution operator. Next, I will introduce the private attribute. In this example, we can directly access member data because their attribute is public. However, if you change its attribute, for example, here I add the private attribute, and now both months and day becomes private. Then I cannot access the two members outside this class. When you try to compile this program, you will find the error message is that months is private, so we cannot access the two members outside the member function. So if you want to modify the values of member data, you need to do it only inside the member function. So if the attribute becomes private, then we cannot directly access the private member data. And this is a convention. Usually, member data is private because we want to hide data from user. We want to protect our own data. So usually, data is under the private attribute. And under the public attribute, usually is the user interface. We usually put some interface usually member functions under the public attribute. For C structures, structures is begins from the C programming language, And in the C programming language, structures only contain member data, and structures do not have member functions. And also, all members the inside structure are public. So structures do not have private. Structures in C do not have private attribute. Next, I will introduce accessor and the mutator. Accessor allows us to read member data, and the mutator allows us to change member data. So now suppose we put member data under the private items. Now suppose we want to access the member data, then we need to provide accessor like getDay. So here we provide user access under the public attribute. So this is a member function. So we need to declare this function, and the getDay will return day, and the day is an integer. So the return data type is integer. And this function accessor has no inputs, and then we can implement this function. The function definition is simple. We just return the value of day. We can access day here because getDay is a member function of this class. So inside this member function, we can access member data. So I can make a function call to getDay to obtain the value of day. And we haven't initialized this member data, so its value is actually unknown. So you cannot assume it to be 0. If we want to set member data, then we need to define a mutator. So now suppose we want to set the value of member day. So this is the mutator. The input is the new value of day, and this function will modify the value of the member data day, and this function does not return any value, so the return data type is void. So inside the function definition, we new day is the function input. We assign new day to the member data day. We can access member data because set day is a member function of day of year. For example, I make a function call to set day, and this will set the value of day to 12. So here, if the member data is private, then we need to use access and the accessor and the mutator to access or modify the values of member data. Because this is to restrict the user from this is to protect our own data. The user can only access data using provided interface. And we have finished the second topic. Next we will have a teaching evaluation survey. So I will call the assistant. Hello. Next, we will have a roll call, and if your name is called, please raise your hand. 陈雅婷。哦，不对。杨佐之，赖胜哲。陈格飞。王鼎文。胡书伟。李佩琪。游之荣。林佳瑜。刘雨婷。谢淑雨。许哲伦。卓振宇。郑凯元。梁宇文。卢义威。钟恩平。王智慧。沈大军。陈柏佑。陈柏佑。潘宏凯。傅佩慈。毛子璇。简胜杰。涂洪宗。黄佑杰。陈以欣。杨义达。丁雨婷。张介阳。杨君玉。林于晴。陈善慈。苏哲瀚。许登军。贾允中。张庭荣。王义凯。卓嘉诚。刘崇言。刘崇言。于希云。严传熙。陈彦伟。林承轩。林宏庭。赖伯宏。周旭甫。周永甫。张耀。严玉君。许家伟。洪胜渊。郑成宇。闵家生。敖伟翔。黄泽燕。蔡佑恩。刘宏伟。伊尔旺。this student ID. 安德里。蔡明贤。黄嘉丽。she takes a leave. 马伊恩。穆明珠。于大宪。孙天寿。陈贝达。叶宇轩。彭科杰。Veronica Kruger。 陈科佑、吕信廷、王汉廷、吴正阳、雅科夫、李嘉恩、吴迪恩、and we have finished the roll call, and let's return to the slides. And we have finished the previous two parts, and I will introduce OOP. So we use class to define our own data type, and our own data type is like built-in data types such as integer or double. So you can perform many operations to our own data type, and we usually call them objects. So suppose if you use class to declare a variable, and the variable is usually called object. And any data type usually includes member data and the member function. Member function is to support operations that can be performed on data. For example, if you want to define a class, for example, matrix, you want to define a data type matrix, and the data of a matrix may be a two-dimensional array, and you want to support some operations for a matrix. For example, you want to support matrix addition or matrix multiplication, then you need to define member functions to perform these operations. And when we define data types, we usually assume that the users don't know the details of about the member data and the operations are implemented. This is known as abstract data type. So abstract means to hide the details. So if your class is well designed, then any programmer can use your class without the knowledge of implementation details. The programmers only need to know the interface to how to use this how to use your class. And in object-oriented programming, we usually separate interface from implementation. We usually define interface first, and later you can start to implement. The benefit of this separation is when we want to change the implementation, and this change will not affect your user because the interface does not change. So the user of your class, don't need to change their code, even if you change implementation, because the interface remain unchanged. Here is one example. Now suppose suppose I want to use sort to sort an array. So the interface is like this. Suppose I want to use sort to sort a vector. So the two input. So this is the interface of this operation, and we don't know the implementation of this sort function. We don't know its algorithm. It is implemented by quicksort or bubble sort or other other implementation. We don't need to care about that. And when the implementation is changed, we don't need to modify this line. So this line remains unchanged, even if the implementation of sort is changed to another algorithm. So this is known as interface and implementation separation. We usually want to separate interface from implementation. Below are principles of object-oriented programming. Usually we want to perform information hiding. We want to protect our own data. And the users don't know the implementation details. So the concepts are similar. Information hiding, data abstraction, encapsulation, are all similar concepts. What we learned so far can be categorized into two types. The first type is procedure-oriented programming. The second one is object-oriented programming. Procedure-oriented programming means we don't use objects. We don't use class. We use functions we use functions to perform operations. And the object-oriented programming means we use objects. We use objects to perform tasks. And you see that for object-oriented programming, the data is inside each object. While for the procedure-oriented programming, we only have local data. Local data is defined inside each function, and we also have global data. Global data means anyone can access this data. So for procedure-oriented programming, we don't have member data like in objects. So both are programming paradigms. Both paradigms can be used. It depends on your interest. You can choose any style to write programs. A higher principle is clean code. So I always emphasize the importance of clean code. So clean code is more important than whether you choose procedure-oriented or object-oriented programming. So clean code means your code is easy to understand. So for example, if you see this image, this is not C++, this is JavaScript, but you can still understand. You can still understand the purpose of this source code. So this is so clean code means your code should be readable, should be well organized. And we usually use functions to separate each task. So it is for this source code, it is easy to understand its purpose. So here, still alive is a Boolean variable. And if this Boolean variable is true, then we enter the while loop. Inside this while loop, we will perform 4 actions. The first action is wear mask. The second action is to stay 6 feet apart. The third action is to wash hands. The last action is to get tested. So the code is easy to understand, and it is also very flexible. You can add any function you want inside the while loop. So the code is readable and flexible. And so we should always you should always write clean code. And we have finished this chapter, and then we will go to the next chapter. The next chapter is constructors. Constructors is a member function, a special member function. This member function is used to initialize member data. So such member function is called a constructor. So in this chapter, I will introduce the concepts of constructors, and also introduce some keywords like const, inline, and static. So let's see this example. Constructor is a special member function. The purpose of this constructor is to initialize member data. So let's see, in this example, the data type is day of year. And the constructor is also day of year. So the constructor has the same name as the class. So constructor has the same name as the class. And another feature is that constructor cannot return value. So for this function declaration, we see we didn't return any data type, and we don't even need to write void. So when we define a constructor, the return data type is empty. We don't need to write void. And so a constructor is also a member function. So after declare this member function, we need to provide implementation. The implementation is outside the class. So here is the implementation of this constructor. And the constructor can have any inputs. The inputs can be empty or a number of parameters. And for this example, this constructor has two inputs, month value and day value. Month value will be used to set the member data months, and the day value will be used to set the value of member data day. So we can try to define our own constructor. So here we need to, this is only declaration. We need to provide implementation. So and here I remove the private attribute. So all members are public, so that I can print the member data. And we see that after this constructor, the member data are initialized to 12 and 12 because of this constructor. You can try to add void to see what will happen. For example, we add void. So this will cause syntax error because constructor cannot so the return data type of constructor is empty. So we cannot write void. This will cause syntax error. Time is up, so let's take a break for 10 minutes. Hello. We can continue our class. Uh, for this example, we define our own constructor. So in this example, we define our own constructor to initialize member data, and the constructor must be in public section, cannot under private, because if it is private, then we cannot use it to we cannot call this member function. So it must be public. And in this example, in this example we declare two objects, date1 and date2. And date1 will have its own data, and the date2 also has its own data. The member data for date1 and date2 are independent. So for this example, we use constructor to initialize date1, and its member data is 7 and 4 respectively. And for date2, the member data for date2 is 5 and 5 respectively. So the member data for the two objects are independent. The next slide is about we cannot directly make a function call to constructor like other member function. So we usually use the dot operator to call member function. However, we cannot use the dot operator to call the constructor. So this is illegal. This will cause syntax error. The correct way is to use parentheses. We use parentheses after the name of the objects. So actually, we don't need to write the name of this constructor. So this is called implicit. We implicitly call this constructor because we do not write its name. We only use parentheses. So this is the implicit way to call a constructor. We can do some experiments. So in this example, here we implicitly call the constructor. If we want to if we want to explicitly call the constructor, we can use So if you want to explicitly call a constructor, you can use this way. So we can directly call the constructor like this. You use the name of this constructor. So this is the explicit way to call a constructor, and the above is the implicit way to call a constructor. So for this slide tells us we cannot use the dot operator to call the constructor. Although a constructor is a member function. The next slide shows another way that we can define the constructor. So if we want to initialize member data, we can use method 1. And this slide shows another method, method 2. Method 2 is known as initialization section. So after the parentheses, we add a column. And after the column, we will specify the initial value of each member data. So for example, after the column, we set the member data months, and we add a parenthesis after this member data. And inside the parenthesis is the parameter, the parameter of this constructor. So the member data months will be set to month value. And we can set, and similarly, the member data day will be set to day value. So this method is known as initialization section. So we can modify our example here. We can use initialization section. So here I use the method 2. So inside the braces is empty, and both have the same effect. And actually, it is very common. It is very common in OOP to use method 2 to initialize member data. The purpose of a constructor is to initialize member data, but we can also have additional operations, such as we can validate the input data to ensure the data is within the legal range. Here is one example. We initialize member data using the initialization section method. And inside the function definition, inside the braces, we use the if statement to check whether month is between 1 and 12, and to check whether day is between 1 and 31. So we want to ensure the member data is within the legal range. So we can also perform validation within the constructor. The next topic is about constructor overloading. A constructor is a function, and we know a function can be overloaded. Overloaded means we can have different versions of function implementation, but using the same function name. So like this, we can have three versions of constructor. So here is the three versions of constructor. The first version accepts two inputs. The second version accepts one input, and the third version accepts no input. The third version is known as default constructor. So a default constructor means a constructor that takes no arguments. So the default constructor is a constructor with no arguments. So here is an example. We can use constructor overloading. If the constructor accepts only one input, then we need to manually specify the value of day. You can set any value, like for example 1. And the parameter is used to set the value of months. For the default constructor, we have no inputs. So in this scenario, we need to manually determine the values of each member data. For example, here I assume the initial value are January 1st. So here I declare data 1 and data 2. And data 1 will call the data 1 will call the first constructor, because the first constructor accepts two inputs. And data 2 will call the second constructor, because the second constructor accepts one input. Then I print date 1 and data 2. So the member data for data 1 is 12, and the member data for data 2 is 12 and 1. And we can create another. We can create another object. For example, data3 that use default constructor. Suppose we want to use the default constructor, and default constructor means no arguments. So suppose we want to use default constructor, and we will have now we need to determine whether we need to add a parenthesis after the object name. So if you compare the previous two versions, for the previous two versions, we add parentheses after date 1 and date 2. And for this example, for default constructor, we cannot add the parentheses. If you try to add the parentheses, this will cause a problem. So the character usage for default constructor is not to add parentheses. So if we want to call the default constructor, we should use this one. This one will call the default constructor. And if you add a parenthesis, suppose you add a parenthesis after the object, then you will have a problem. So we see that we have error message. So first we see a warning. So a warning is in line 26. So this calls a warning. So this line is legal. So for this line, this line is legal. If you compile this program, we only have warning but no error message. So this line is legal. And if you read the warning message, the warning message suggests to remove parentheses, because if we want to use default constructor, we need to remove parentheses. So if you add a parenthesis, this means we are declaring a function date3. So if you write a statement like this, this means we declare a function date3. So this is different from make a function call to a constructor. So this is function declaration. So this is function declaration. We define a function date3. This function has no input, and the return data type is day of year. So for this line we declare a function date3. And clearly we do not have object date3, so we cannot use dot operator to access member data, because we don't even have objects. So the line 27 cause syntax error. So we see that for line 27, data3 is not an object. Data3 is a function, because this is a function declaration. So since it is not an object, we cannot access member data. So if we need to create an object, we need to remove the parentheses for default constructor. So default constructor means a constructor with no arguments, and this can be confusing because we usually use parentheses for constructors. So this can be confusing. If you add the parentheses, this means we declare a function. So compiler will think you are declaring a function. The next slide is about how to explicitly make a call to constructors. We already learned this. So you just write the name of a constructor. So this is the explicit way to call a constructor. So implicit way means we use object. We use object followed by a parenthesis to this is the implicit way, and the explicit way is to directly call the constructor without objects. So in this line we didn't create. We don't call this constructor through an object. And if we want to make a function call to default constructor using the explicit way, then this time we need to add a parenthesis. So this is different from implicit way. For implicit way, we need to omit parentheses. But for explicit way, we just use constructor like ordinary functions. The next exercise is a self-test exercise to test your knowledge about constructors. So let's see the definition of this class. So for this class, we have two member data information and more information. And we have two constructors. The first constructor accepts two inputs. The second constructor is the default constructor. The default constructor accepts no inputs. The definition is shown here. The new info is used to set new info is used to set the member data information, and more new info is used to set the value of more information. And for the default constructor, we have no inputs. So here we manually determine the value of information to be 0 and more information to be character A. Then we can start to use this data type. We can use your class to define to declare objects. So here we declare objects. So the first statement declares object 1, and this will call the first constructor. And because this constructor accepts 2 inputs, and let's see the second line, the second statement. Suppose our intention is to declare objects, and suppose our intention is to declare objects, and you can determine whether object 2 is legal. Legal means the semantic is correct. So you can determine whether this statement, the semantic of this statement, is correct. If you think its semantic is correct, please raise your hand. If you think it's semantic, suppose we want to declare objects. If you think its semantic is correct, please raise your hand. And if you think it is illegal, so if you think its semantic is wrong, please raise your hand. If you think its semantic is wrong. Oh, okay, very good. Its semantic is wrong, because its semantic is to declare functions. So its semantic is not to declare objects. So the semantic of this line is to declare functions. If we want to declare objects using default constructor, we need to use the third statement. So the semantic of the third statement is legal. And the next example is to use the explicit constructor to declare objects. So here we use the explicit constructor, and the explicit constructor is like functions. When we make function call, we always use parentheses. So the first two function call are legal. For the last statement, we omit the parentheses, and this will cause syntax error. Because if you remove the parentheses, then this is not a function call. This is a data type, and we cannot assign a data type to an object. So if you write this line, this causes syntax error. So we can try some, we can do some experiments. If here we omit the parentheses, then we see error message. So because day of year is a data type, you cannot accept, you cannot assign a data type to some variable. So here we need to add a parenthesis, and this will call the default constructor. So its value is set to 1, 1. So this is the definition of the default constructor. The next slide is about some details about default constructor. Sometimes default constructor will be automatically generated, and sometimes not. So and when will a default constructor be automatically generated? The scenario is that if no constructor are provided. In this scenario, a default constructor will be automatically generated. However, if we already define some constructor, and in this case, the default constructor will not be automatically generated. In our example, we already defined 2 constructors. So if you omit the default constructor, then here we omit this default constructor, then we cannot make a function call to the default constructor. If you try to do this, we see the error message because we do not define the default constructor. So no matching function call for this statement. And then you can try to remove all the constructors. Now I remove all the constructors. And you see that this time the program can be compiled. You see that the program finishes correctly. So this means default constructors is automatically generated. So I can perform this statement. This statement will call the this statement will call the default constructor, and the default constructor is automatically generated because I didn't provide any constructors. So here are some details about default constructors. The next slide is about class type member data. For example, one of your member data is class type. And when we try to initialize, when we want to define a constructor. Here we want to define a constructor. Then we need to initialize this. We need to initialize date, and we will use the constructor for this class type. So this parenthesis means a constructor. We implicitly call the constructor to initialize months and day. While for the Boolean data type, the parenthesis is not the constructor. So because parking enforcement is a Boolean data type, this is not a class type. So here, parenthesis is not a constructor. The next slide is about how we can pass parameters, how we can pass class type parameters. We can use call by value or call by reference. And again, call by value causes some overhead because you need to copy member data, all the member data. So call by value causes some overhead. While call by reference is more efficient because we only need to send memory address of the object. So we usually prefer the method 2. When we want to send some object, we usually use call by reference. And if you don't need to modify date inside this function, then we will add the const modifier. This is to protect you accidentally modify date inside this function. So here const depends on your application. If you need to modify date, then you need to remove the const modifier. So when we deal with objects, we usually use call by reference because it is more efficient than call by value. And we have finished the first topic. We have finished the introduction to constructors. Next, I will introduce the second topic. The second topic is about three keywords: const, inline, and static. We can add const. We can add a const after the parentheses. For example, here we define a member function getMonths, and you can add the const keyword after the parentheses. This means we cannot modify member data inside this function. So const member function cannot change the value, the member data of the calling object. Now suppose I define the member function get months, then we can use this function to get the value of months. So this function call will return months, and the initial value of months is 1 because we call the default constructor. So the value returned by this function is 1. Now we can try to do some experiments. For example, you can try to modify the value of months inside this statement. So if you do this, then the value of months is increased by 1. So here the get months will return 2. And we modify member data inside this function. Now you can try to add the const keyword. Suppose we add the const keyword after the parentheses. Then in this time we cannot modify member data, because if you declare a const member function, then this means you cannot. The member data becomes read only inside this function. So the member data is read only inside the get months function, and therefore you are not allowed to modify member data inside this function. So this will cause a syntax error because months is added by 1. So months is read only. If you do not modify its value, then the program can be compiled. So here the use of const will protect all parameters, will protect all member data. So if you don't need to modify member data, you can add the const keyword to protect your member data inside this function. And it is all or nothing. which means if you use const, it will protect all the member data. And if you don't use const, then all the member data can be modified inside this function. Previously, we know that when we declare two objects, layer member data are independent. So the member data of date 1 is independent of the member data of date 2. But sometimes we want to share data across objects of the same data type. So for example, sometimes you want data 1 and the data 2 to share some common data. And this is known as static member data. So if you want some data can be used across objects, then you can use static, the static keyword. And the same concept applies to functions. If you want some function can be used across objects, then you declare static functions. And this topic will be covered in the next week. And I think our today's class is almost over, so we can now dismiss.